So our degrees, what are the degrees in the first quadrant?
0, 30, 45, 60, 80.
Did everybody get those? Okay. Because those are the same ones as on our hand trick. Okay, from there, let's jump over here. What would this angle be?
180.
And then remember, when we talked about this, we used reference angles. We said, okay, think about like, these are all 30 degrees from the x-axis. These were 45 degrees. If I could draw a straight line. And are 60 degrees. So then we used our reference angles to fill in the rest. So what would this angle be?
150.
180 minus 30 is 150. This one would be 180 minus 45, 135. 180 minus 60 is 120. And you should catch it if you do this wrong, because your angles should be increasing as you go around. If you flip two of them, they won't be increasing. So you'll catch a mistake that way. Okay, in the third quadrant, we have to add our reference angles. So 180 plus 30 is 210. 180 plus 45, 225. 180 plus 60, 240. What's this down here? Yep, 180 plus 90 is 270. And then when we went back here, this is 0 degrees, 360 degrees, they're the same. So you do 360 minus your reference angle. So 360 minus 30 is 330. 360 minus 45, 315. 360 minus 60 is 300. All right. Did we get the angles and degrees? Any questions about the degree measures? Okay, let's talk about our radians. We said before that pi radians is equal to 180 degrees. So to change degrees into radians, you could just multiply by pi over 180. And that's how we originally got it going all the way around. But obviously, we don't want to have to do every single calculation as we go around. So let's kind of talk through some of these. This was 0. If you take 30 times pi over 180, we get pi over 6. 45 times pi over 180 is pi over 60 times pi over 180. 90 times pi over 180. Okay. So do you understand how I got those? Notice my denominator is just getting smaller as we go up. All right, let's jump over here. What would 180 be? What would 270 be? 360 is the same as 2 pi. Basically, you're adding pi over 2 every time. 0, pi over 2, 2 pi over 2 is pi. 3 pi over 2, 4 pi over 2 is 2 pi. And then we said everything with a reference angle of 30 will still keep that denominator of 6. All the angles with a reference angle of 45 will have that denominator of 4. Everything with a reference angle of 60 would have a denominator of 3. And we also talked about the patterns as we went around. In the first quadrant, it was just pi on top. In the second quadrant, you would have to think pi minus something. So what's the pattern? The top is? Right. 1 less than the bottom. So 1 less than 6 would be 5 pi over 6. 1 less than 4, 3 pi over 4. 1 less than 3, 2 pi over 3. Okay, in the third quadrant, you've gone past pi. So the top is 1 larger. So 1 more than 6 would be 7 pi over 6. 1 more than 4, so 5 pi over 4. 1 more than 3, so 4 pi over 3. All right, in the fourth quadrant, we talked about it's really like doing 2 pi minus your reference angle. So it's double minus 1. So 6 times 2 is 12, minus 1 is 11 pi over 6. 4 times 2 is 8, minus 1 is 7, pi over 4. 3 times 2 is 6, minus 1 is 5, pi over 3. All right. Any questions about those? What I want you to do now, I'm going to put a few problems up here and I want you to try them. You can do them in your notes. You can do them on the back of this unit circle if you want. These are all review problems that we are doing on the last test. We had a section like this, so remember the work. You should write down quadrant and reference angle. So we're doing some review today. 5, what quadrant? In quadrant 3, tangent is positive, so secant would be negative. Reference angle, 45 degrees. Okay, so cosine of 45 is radical 2 over 2. If you flip it, you should just get negative radical 2. All right, sine of 30. We don't even need quadrant and reference angle, it's just quadrant 1. So the sine of 30 is? Okay, sine of 330. What quadrant is 330? Reference angle. Okay, so in quadrant 4, cosine's positive, so sine is negative. The sine of 30. All right, 120 is in quadrant. Reference angle, 180 minus 120 is 60. In quadrant 2, sine is positive, so cotangent would be negative. Okay, when I think cotangent, I'm thinking about tangent. Tangent of 60 is radical 3 over radical 1, so cotangent would flip it, radical 1 over radical 3, or negative radical 3 over 3. Sine of 210, what quadrant? Reference angle? Okay, in quadrant 3, tangent's positive, so sine is negative. The sine of 30 degrees, 1/2. All right, cotangent of 60, I don't even need quadrant and reference angle here. Tangent is radical 3, so cotangent would be cotangent of 135. What quadrant is 135? Reference angle. In quadrant 2, sine is positive, so cotangent's negative. Tangent of 45 is radical 2 over radical 2, so 1. Reciprocal is also 1. 270. Okay, you might need to think about that. There's different ways you could think 270 is right here. That's the point 0, negative 1. That's how we did it initially. You could also think of it in terms of hand trick. It's kind of like a reference angle of 90. So tangent is y over x. So cotangent would be x over y. Or if you think about like tangent of 270 would be radical 4 over 0. So cotangent, flip it, 0 over the square root of 4. Either way we get 0. Okay, 180. Couple ways of doing it. You could think about here, this is like the point -1, 0. Cotangent, x over y. Can you do -1 divided by 0? No. If you're doing hand trick, that's like a reference angle of 0. So tangent is 0. Cotangent would be the reciprocal, which is undefined. All right, so we are reviewing these because they're not going away. Okay, we still have these same types of questions. How did we do on those? Good? All right, so now I'm going to put a few up for you to try, but these are going to be in radians. Now your strategy is the same. You think quadrant and reference angle, and then do your hand trick. I might throw a few more up here. Could you go through and convert every one of these into degrees if you needed to? Absolutely. How would I change them into degrees?
80 divided by 6.
Yep, you would, essentially you're taking it times like 180 over pi, so the pi's cancel, 180 divided by 6, it's 30 degrees. Now, is that what I want you to do every single time? Not really, not that it's wrong, but I want you to get used to seeing radians. I don't want you to see them as something you have to change every time. So when you see pi over 6, We know 180 divided by 6 is 30, so I'm thinking 30 degrees. The sine of 30 degrees is just 1/2. Okay, when I see 3 pi over 4, in which quadrant is the top less than the bottom? In which quadrant am I going to circle? 2, because you're not quite to pi yet. Okay, reference angle. All you have to look at is the denominator, pi over 4. Or if you're thinking degrees, that is 45 degrees. 180 divided by 4 is 45. That's where it comes from. Okay, in quadrant 2, sine is positive, so cosine is negative. Cosine of 45 degrees, radical 2 over 2. Do you guys see where I'm getting these? Okay. 5 pi over 3. Okay, in the first quadrant, it's just pi over something. In the second quadrant, the top's 1 less. Third quadrant, the top is 1 more. Fourth, double minus 1. What quadrant is this?
4.
My reference angle is just pi over 3. I'm fine if you just write pi over 3. If you do degrees, that's 60 degrees. I don't care which one of those you write. They're equivalent. So in quadrant 4, cosine is positive, so tangent would be negative. The tangent of 60 degrees is all right, 7 pi over 4. What quadrant is that? Reference angle. Pi over 4 is in quadrant 4, cosine's positive, so cotangent is negative. Cotangent of 45 degrees is 1. 2 pi over 3, what quadrant is that? 2. The top's 1 less, that's the second quadrant. Reference angle, pi over 3, or that's 60 degrees. In quadrant 2, sine is positive, so cosecant would also be positive. Okay, the sine of 60 degrees is radical 3 over 2, so cosecant would flip it. So you get 2 radical 3 over 3. And secant of 3 pi over 2. You can't really name a quadrant here. That's the same thing as saying 270 degrees. If you're trying to use hand trick, it's like a reference angle of 90. So cosine square root of the bottom over 2. Cosine is 0. So what does that mean secant is? What's the reciprocal of 0? Undefined. If you go back to this, secant is r over x. So 1 over 0 is undefined. All right, so these are the same questions. It's just I gave you a different unit to start with. Are we okay with those? What do you think you would do if I gave you, let's say, the sine of negative 5 pi over 4? When we had degrees, if I gave you a negative degree measure, what did you do? We didn't just flip it, though. How did we make it positive? We added 360. Or if I gave you a really big angle, you would subtract 360. Okay, in terms of radians, 360 degrees is the same thing as what? All the way around the circle is? 1 full rotation, and that's 2 pi. So if you have a negative angle, you can add 2 pi to it. If it was a really big angle, you could subtract 2 pi, just like we added or subtracted 360. You're welcome to use your calculator, just don't put in the pi's. Do negative 5 over 4 plus 2. I'm not going to judge you if you get hung up on the fractions, okay? You can use them. So negative 5 over 4 plus 2 gives you 3 pi over 4. And then this is one we could evaluate, right? That would be the second quadrant. Reference angle pi over 4 or 45 degrees. The second quadrant, sine is positive, sine of 45, radical 2 over 2. So if you have a negative angle in radians, you add 2 pi. If you have a really big one, you can subtract 2 pi. Any questions about these? This is where we had ended class Friday. We had just practiced a few of these. The last question I have today Through how many radians does the hour hand on a clock rotate in 24 hours? So we have to think a little bit. I'm asking for radians, so not a degree measure, a radian measure, so like with our pies. But I asked about the hour hand on a clock. So think about the hour hand. In 24 hours, how far does the hour hand move on our clock? 2 times around. Can we agree? Now, the minute hand would be different, right? So it does depend on which hand I'm talking about. So 24 hours is 2 times around the circle. Every time you go around the circle, how many radians is that? 2 pi. So we have 2 pi twice. So just 2 pi times 2, which is 4 pi. No unit required because it's radians. If we were doing degrees, we know we have to put a degree measure. All right, so if I want how many radians does the hour hand move in 4 hours? Is that one as easy? Okay, so we would have to figure out how much of the clock have we traveled. We know 2 pi is all the way around, but in 4 hours, how far have we traveled? It's not even a full rotation, is it? A third. All the way around is 12 hours, so 4 hours is 1/3. So this would be 2 pi times 1/3, or 2 pi over 3. That is the end of this